But let me just sort of tell you that if you don't know Nina, she's an icon in the field of music cognition. Her creative approach to science, but also the communication ability she has surrounding science is really unparalleled. Nina just has a gift in delivering ideas and speaking about ideas in a way that anybody could understand it, no matter what their background is. As Ani alluded to, she's studied an amazing array of topics, not only in hearing, but also music cognition, and has been one of the primary drivers in developing the field, not just in the US, but also internationally. Personally, I'm very grateful to her for years of friendship, and I've admired her work throughout. Thankfully, she has a book it's called Of Sound Mind, How Our Brain Constructs a Meaningful Sonic World, that's going to be published in the fall. And today she's joining us speaking on making music sharpens sound processing in the brain for language. Nina Kraus, thank you.
All right, can you hear me?
Yes,
Yes, everything good?
we hear you.
All right, and you can see the screen?
Yep.
All right. I get to talk about something that I love to talk about, and I'm standing up and trying to imagine that I'm actually looking at real people. So it's important that we have an imagination. But I get to talk about how music sharpens sound processing in the brain for language. I want to time myself. So, all right. Okay. So we know that sound consists of many ingredients, and this is the great group. It knows all about frequency and amplitude modulation and the harmonics and timing and timbre, pitch, phase that are involved in just any sound as I'm talking to you right now. And so, we have these sound ingredients, and the brain needs to make sense of them. So, a metaphor that I find really useful is a mixing board. So each one of us, depending on our lives in sound and depending on our experience with sound, the sound to meaning connections we make, are going to enhance certain aspects of sound processing and distort, diminish other parts of sound processing. And we have been very happy to be able to access sound processing and all of these different ingredients. Again, look at the faders on the mixing board. You can deliver sound with earbuds and just with a handful of electrodes, measure the frequency following response, and we can see how good a job the brain is doing at processing these particular ingredients. So we're really able to look at each one of these. And also we can play back the sound and get us we can play the brain's response to sound, so we can get a sense of first of all what we're able to pick up. So here is a stimulus. Here's the brain's response. So, but what I really want to show you here is how our life in sound creates a unique sonic fingerprint for each one of us. So here what I have are 6 frequency following response to da. And what you can see is the response in the time domain and in the frequency domain. And now I'm going to show you for each person a frequency following response obtained from that person a few months later. Subject 1, 2, 3, 4, 5. Okay, so I hope that you have seen how incredibly personal our response to sound is. So if you listen to a clip like this, I want you to listen to these are 3 healthy brains, and you can just hear how their brains are processing these sounds differently. That's brain 1. Here's another brain. And here's a third. Okay. And of course, we are tuned to the sounds of our own instrument. If you are a pianist, your frequency following response will more accurately and clearly represent the sounds of your instrument than the sounds of another instrument. And again, if you are if you play a different instrument, then that instrument will also be enhanced. And I really would like to point you to a recent tutorial that we just published in Hearing Research. And it really puts out there all in one place how much information you can get from the frequency following response. And it's a tutorial for decoding the richness of auditory function. So just given a complex sound like speech, and the brain's response to that sound, there's just a tremendous amount of information that you can extract from that and learn about people's strengths and deficits and monitor treatments and therapies. So the hearing brain is vast. Of course, we have our afferent pathway and our typical auditory system. We also have descending pathway. But importantly, and as Ani was talking about, our auditory processing is influenced by how we feel about sound, how we think about sound, how we move with sound, and how our other senses come to bear with our perception of sound. And there have been elegant experiments in animal models showing how individual neurons change based on the reward or memory or movement, multisensory demands. Now, I want you to take a look at this and see how, again, this is a schematic of the afferent pathway, these blue lines connecting the ear to the brain. And here's the efferent system then connecting the whole thing. And what I really want you to realize is how, the auditory midbrain is in the middle of the action. And we know that the frequency following response arises largely from the auditory midbrain as well as other areas. But I really want you to think of it as this is not just a midbrain response. This is a response that reflects the interaction of all of the different areas of the brain that course through the midbrain, going upstairs and downstairs. So we really cannot think about the frequency following response, or the auditory midbrain for that matter, as being a low-level response. And I will talk a little bit later about how I think learning really changes this infrastructure, and how we can think about how the auditory system is coding our auditory experience, otherwise known as our auditory memories. So we can get information about this entire network through the frequency following response. And as I said, I will touch on this idea of how our experience in sound then creates us, our sonic selves, and the memories that we have for the sound of our name. Now, music arguably is the jackpot for engaging our cognitive, sensory, motor, and reward systems. And that's why I would like to now tell you about a number of experiments where we and others have measured sound processing in the brain and tried to look at what is the impact of musical experience on the brain's processing of sound. And in a number of these studies, we have found the mighty da to be incredibly a useful stimulus. First of all, it exists in almost all of the world's languages, and it consists, just this da consists of a number of ingredients we're really interested in. It has all kinds of timing features, including the onset and offset, but all kinds of other timing in between, FM sweeps, the fundamental frequency, and the harmonics. And all of this, how good a job the brain does at processing these different ingredients is available to us in the FFR to speech. And what we have learned is that there's a musician signature that in particular enhances the encoding of timing, FM sweeps, the harmonics. And this is something that we see across the lifespan, and something that also grows across the lifespan. And what is important is that with respect to this issue of transfer, right, is that these same three components, which are what we deem the musician signature. This is the way in which musicians' response to sound is strengthened. They have strengthened representation of the harmonics, the timing, and the FM sweeps. And it turns out that language, these are exactly the three components that we need to have strong language skills, and these are the components that we see diminished in individuals who have language impairments of one kind or another. Again, Ani touched on emotion, and how musical experience can help us process emotional elements in sound. And so again, here is the frequency following response that is recorded to a baby's cry. And what we can see in the musicians is enhancement of the harmonics, which is this area here. This is the part of the response to the sound, and it is the part of the baby's cry that informs you whether your baby needs his mommy or not, or whether he's just kind of crying. And interestingly, in the non-musicians, you don't see this enhancement of the harmonics, so you don't have this really important bit of meaning information. But what you see actually is an enhancement, an over-enhancement of the fundamental frequency, because that's a simpler part of the sound, and it's the only part that the non-musician has good access to. So that seems to be enhanced. With aging, we know that a number of components in sound processing are diminished. And what is incredibly encouraging, again, here we're really looking at this issue of transfer through the lens of sound processing in the brain and these different ingredients. And we can see that an older musician has really good processing of these different components that in other people often get degraded over time, which I think may be in part responsible for some of the language and the ability to hear better in noise that we see in musicians, older musicians. So let me now really put a spotlight on rhythm and language, as Ani promised you. And one of the things that we've been doing in my lab is looking at rhythm abilities, so drumming abilities, and then measuring responses to sound and various other cognitive responses and academic achievement in the same kid, right? And what we're able to see is that in the kids who are good at synchronizing to a beat, these are the kids who their frequency following responses, their brain responses follow the rhythms in the speech sound. And so you can see that in the synchronizers compared to the non-synchronizers who are just missing that information. And of course, what is very important with respect to the synchronizers and the non-synchronizers is the synchronizers have better language skills. So it's not just a matter of being good at rhythm. And, this is one of the many ways that I was wrong in my hypothesis. I thought that if you were good at one kind of rhythm task, you would be good at all kinds of rhythm tasks. And, we have a whole battery of different rhythm tasks. And if you take something like Who Stole the Cookie from the Cookie Jar, you can see that it has a beat, right? So who stole the cookie from the cookie jar, right? And it also has a pattern. Who stole the cookie from the cookie jar? And what is interesting about this is that you cannot predict how well a person is going to perform on a pattern skill task from how well they perform on their beat following tasks, and vice versa. So this is, I think, very interesting that there really are different, very identifiable aspects of rhythm, and they're both in music. The beat is telling you where the one is, and it's delineated by the time signature, and the pattern is represented by the note values. So, music has both pulse and rhythm patterns. And if you now look at sound processing in the brain and various ingredients, what we see is that the beat keeping, kids who are really good at the beat keeping task have elements of microsecond and millisecond timing, very fast timing that aligns with their beat keeping performance, whereas the kids who are good at pattern production aligns itself rather with brain activity that's happening over a longer time scale. And of course that makes every sense in the world, because for a measure to unfold or for a sentence to unfold, you need time for that to happen. So strengthening rhythm, one of the great ways is to do it through music. And there are a number of technologies that also can help, in addition to music, to help from a clinical standpoint. And we have done some work with interactive metronome, and the word interactive is a really important word here, because the program really interacts with the person, or the sound and the vision and the movement of the person, and the cues that you're getting from the program. And it's an interactive way, and the program changes adaptively depending on your performance. This gives us information about people's rhythm abilities, and it's something that can be trained. And one of the things that we have found interesting is that, as I said, this brain activity that's occurring over microseconds and seconds that generally aligns with beat keeping and pattern production separately and, distinctly, that interactive metronome actually seems to pattern with both pattern and beat keeping skills. So we find that kind of interesting, and I think that there are good reasons for that. So what about music and language? Again, one of the best ways of looking at this is to perform a longitudinal study where you have kids, a group of kids, and you match them with a group of kids doing another enrichment activity. And what we're really interested in is looking at sound processing in the brain over time. And we've been able to do this in a number of studies, both in Los Angeles and in Chicago public schools, where we've been able to follow the same kid, because that's one of the strongest experimental models we have, to follow the same kid over 3 and 4 years. And all of this work happened in low-income neighborhoods in both Chicago and in Los Angeles. And here are some of our wonderful kids, and they really enjoy getting their brain responses tested, because they just get to relax. we found that in low-income areas, in the kids who did not receive music, we know that there is an achievement gap, and the reading scores decreased from year to year, but did not in the music group. So in the music group, the kids were able to maintain their age-appropriate reading levels year after year. With hearing a noise, so this is just hearing sentences and noises or hint sentences, we saw no difference, no change in the two groups after 1 year of musical training. But after 2 years, we saw a significant improvement, a significant difference in the children who played music, and their music was for 3 to 5 hours a week, plus what they practiced. And over 2 years, we saw this change. We can see neurally, both in the imaging and in the brain's response to sound, that musicians have very robust responses in both favorable and unfavorable conditions. And the non-musicians have very robust responses in favorable conditions, but it breaks down in the unfavorable conditions. We were very interested in looking at the signature of linguistic deprivation, which often accompanies poverty. We know that kids whose moms have less education generally have less linguistic stimulation and experience. So what we did in our Chicago public schools is we simply divided the kids, same classroom, same school, same teacher, based on their mom's education, and looked at sound processing in the brain. And what we found is that both the response to the sound ingredients was diminished, and on top of that, there was much more background neural noise in the kids whose moms had less education. And we were interested to see, okay, so given this linguistic deprivation signature of decreased harmonics, timing, stability, and increased neural noise, could this be partially offset by making music? And in fact, we found that the neural noise did not change. So the children the children continued to have excessive neural noise. However, sound processing in the brain was enhanced after 2 years of music making. And I really want to mention, especially because of what came up in the previous talk, is bilingualism. So the bilingual signature is a different signature, but it also does enhance sound processing in the brain. And specifically, I need to tell you that it enhances the processing of the fundamental frequency. So this is exactly in line with the work that Ani talked about earlier. And I encourage you, if you look under bilingualism on my website, you will find all of those studies, including one that shows that bilinguals are poorer at understanding speech in noise because of the linguistic demands, and they are better at perceiving non-speech in noise. So anyway, please check that out. It does take time to change the brain. We only saw changes in sound processing, so this is going to get to the sort of my final points of changing sound processing. Fundamentally changing sound processing in the brain takes time, but we saw it whether the kids had their music lessons in school or after school. I want to tell you a little bit about rhythm and traumatic brain injury. We are doing quite a bit of work these days on concussion and sound processing in the brain, and it turns out that concussion disrupts sound processing in the brain. This is something that we have learned. We have an R01 with NIH and where we're studying our Division I athletes, and also we have some studies where we've been able to look at adolescents in sports medicine clinics. and look at sound processing in the brain. But here are some of these that are wonderful Division I athletes who are adorable, I think. Back to rhythm technologies, again, there has been work, and Eric, I'm sure, knows about this, in the veterans with traumatic brain injury. There have been studies showing that following a course of interactive metronome, they observed improvements in memory, cognitive flexibility, inhibitory control, and attention in the soldiers who had gone through the interactive metronome program for about 2 months compared to business as usual. And we've been looking at this now in our adolescence, where, again, with interactive metronome, we find that most of the kids, our control kids, perform perfectly well with respect to interactive metronome norms, whereas 32% of the kids who sustained a concussion had abnormal rhythm performance, again, measured by interactive metronome. And of this 32%, really a large percent has what is deemed to be severe rhythm deficiency. So we really do think that this is a line of work that I would love to see strengthened, and I think it would have implications for the use of rhythm in neurologic disorders in general. Again, here, let me see what I have here in terms of, I think I'm gonna skip, this is more data showing, making the point for kids recovering from concussion and how their rhythm skills also recover. But I do want to tell you about sound processing in the brain in our athletes. So, we have these Division I athletes at Northwestern, 500 of them, males, females, all kinds of sports. And we wondered, is sound processing perhaps is it distinctive in these athletes? And so, we measured all of the different ingredients, but in particular, I've been talking about harmonics, timing, and stability, but we didn't see any difference in sound processing in the brain in our elite athletes compared to our just Northwestern students who weren't elite athletes. But what we did see is that the elite athletes had less neural noise. And this ends up being a boon for the signal to noise ratio, because if you look at this cartoon of a typical person, here you have sound processing in the brain and you have neural noise in the background. The athlete will have the same sound processing in the brain, but if he has less neural noise, he's going to have a better signal to noise ratio. Similarly, you can take your musician, and the neural noise is the same in the musician as in the typical person, but the signal is enhanced. So it's interesting to me to see how sound processing in the brain and the signal to noise ratio can be enhanced based on different people's lives and experiences, and how the athlete and the musician both have a better signal to noise ratio, but they do it in different ways. So my final point here is that the hearing brain is vast, right? So it consists of here is our afferent pathway connecting our ear to the brain. It is our default system. It is one that is kind of slow to change. And of course, this whole system is being influenced by our cognitive, sensory, motor, and reward pathways. And then we have our efferent system, which is more malleable and it changes easily. And the idea is that with experience changes the default state. So experience will then actually change sound processing in the afferent system, such that the automatic default response to sound is is changed and altered based on a person's experience. And I think, one of the best experiments that shows this is one that Ravi Krishna did, where he looked at tone language speakers and found that their FFRs were able to follow tone contours much better than speakers who were not speakers of tone languages. And importantly, this enhancement of processing tone contours, pitch tracking in the Mandarin speakers, this happened while they were asleep. So, it's this active sound to meaning connections that are made again and again and again over years that finally changes the default processing system of the brain. And this is my view of how memory for sound is ultimately, our longer term memories are encoded in our afferent pathway. And we can think of more shorter term memories being more efferent aligned. Okay, so summing up, music shapes sound processing in the brain. FFR is a way to quantify how this happens. Music enhances processing of specific sound ingredients. Sound ingredients overlap for music and language. And we see rhythm for language and traumatic brain injury as possibilities for looking at sound processing in individuals. I just want to make sure that I tell you, as you all know, that it takes a community to get any science work and insights done. These are the alumni who have come through the lab as postdoctoral and doctoral fellows over the years. These are our educational partners that we interact with. This is our music community that we work with. Here's our clinical community that we work with, our athletic community. This is Brain Volts today on the ground. And I encourage you, please, 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 to visit our website that we update really every day. And on the upper right of the homepage, you'll see our website tour, which it's a new feature, and it will take you about 2 minutes. I encourage you to take the website tour so you can find what you're looking for. Thanks.
Thank you, Nina. We have some questions for you. From Hari Gauradadri, modern hearing aids mostly do sub-band amplification to improve intelligibility. Your slide showed many more sound ingredients. Do you think it's beneficial to manipulate other ingredients to improve age-related hearing loss?
Yeah, absolutely. And this is, I think, thank you so much for bringing that up and for that question, because I think that looking at devices and looking at how devices process sound in the brain, for an individual, whether they be older or younger, but have a hearing loss, this can tell us a lot about what the device is doing or not for that person. And yes, I do think that improving devices can be informed by the biology. And I want to mention that my colleague Samira Anderson at the University of Maryland is really doing quite a bit of work along these lines.
Great. Earlier, I had missed a question from Dr. Rob to Dr. Patel, and I have asked Dr. Patel to respond to Dr. Rob offline. From Lisa Hunter. Have kids exposed to enriched music training increase their enjoyment of music, or do you think music enjoyment is more innate?
That's a really difficult question I don't know the answer to that question. I think as Ani said, this is something that as scientists, we should probably keep track of. We should do a better job keeping track of that particular variable. But it's very clear that, we do learn what we care about, even if we hate it. We have an emotional response to it. So I think that's a very important component. Thanks, Lisa.
From Eric Allen, great talk. The Nelson 2013 paper found improved cognition from the interactive metronome. How do you think about this connection between rhythm and cognition?
Yeah. So rhythm and cognition, there have been a number of studies, not specific, there have been some very specifically with interactive metronome, but there have been a number of studies linking rhythm performance, on a task like interactive metronome with cognitive demands. And so one of them especially is attention. So that we know that there are some kids with attention deficit disorder who seem to demonstrate improvements after engaging in rhythmic activities. And Adam Ghazali has some interactive software that is kind of speaking to that. But in concussion, in head injury, so much of the symptomatology, which affects sound processing in the brain, is cognitive. There is an inability to focus. There is an inability to pay attention to the proper signal in the noise. You need to be able to hear, the sound of your feet and of your coach and everyone else talking to you. So I think that rhythm really has a place, and it's something that I would like to see studied really carefully over a group of recovering athletes. I think that athletes are a really good model because they don't have a hearing loss.
Thanks. And one last question from Shirley Henning. Do you have any plans to expand your research with children in low-income neighborhoods to other cities?
This is something that we think about all the time, and we have some plans in the works. It's kind of a matter of working out the logistics and the funding, and but what really seems to work is for people to collect data on site in other places, and for us to be able to try to make sense of it with respect to the sound processing in the brain, because you need to have the kind of expertise that everybody in this room has with signals in order to make sense of the physiology. So yes and no.
In response to your last question, Eric Allen responds, thanks, I'd love to do that study. And then we also had Dave Faber with a question, based on current knowledge, would you recommend processing differences in devices for those with musical experience versus those without musical training?
Yeah, great question, David. I think that audiologists, first of all, need to always ask, you have, context is so important. And so you always have the context of your patient. And so, who is the person that you are dealing with, and do they have musical experience? How important is it to them to be able to hear music well? And I think I would rather have musician enhancement options that could be tried for individuals based on their needs, and I think that the possibilities are huge there. And I think it goes beyond music and not music, because even people who are not musicians, they care about music. In some poll, looking at what do people care about the most? Way up there with eating chocolate and hugging babies is music. People really care about music, and so they want to be able to process music through that hearing aid, and being able to work with an individual to enhance that for that person based on the brain that they're bringing to you. I think is kind of a new world for us to be able to maybe make a little better.
Well, thank you, Nina. I want to just thank you again for a wonderful talk and for your being here today, and really appreciate your thoughts as always. I'm going to invite